Okay, so this will be an introduction to the binomial theorem, building up off of our discovery activity. The binomial theorem is stated as follows. So if we have any binomial, so remember if we have something like x plus y, binomial means two terms. So that's what we're looking at there. We've got two term raised to some sort of power. Is going to be equal to, and this is going to help us with our expansion. Now I'm going to write down this notation. It might be unfamiliar, and we'll talk a little bit about it. So this is what the theorem itself looks like. And notice we're going to put some n choose k in here, that notation that we just finished off our discovery with. And then we're going to put in each of the pieces of our binomial here. Okay, so I'm going to talk to you just a little bit about this. First of all, what is this crazy notation you see right here, right? This is the Greek letter sigma. This is a capital sigma. And sigma just means it's the sum of each term created by inputting the integer values. So I'm going to write this out, and then I'll explain it just a little bit. So this is the sum of the terms, I should say the terms, created by inputting the integer values from k to n. So it's just a shorthand way of saying, for example, that there are like 8 different, well technically 9 because there's a 0th term, that there's 9 terms here. And so we would say that if we were putting this into the binomial theorem here, we would say the k values, or these values right here, range from 0, because that's where it starts, up to n. And we could say we're going to look at it up to 8 and start at 0. So we could express this in that way. And then it's just saying that any of the terms where we put n in as our integer value, and k, we take the first piece of the binomial and we input it here, the second piece of the binomial, and input it here. So I'm going to kind of work through part of this with you. This says use the binomial theorem to find the third term of the expansion. So again, if I'm finding the third term, this is what I want you to realize when we use it, is that this always gives us that n value. Notice in the binomial theorem, your n value is what it's raised to. So I'm going to write n is going to be equal to 5 as I plug into this theorem. Then I move to the pieces, the k value, because the k value tells us kind of the other part of our theorem here, which term that we're trying to find. Now, I want you to recognize in our binomial expansion using this combination notation for our Pascal's triangle, it starts with the 0th term. So k is equal to 0 in the first term of your expansion. K is equal to 1 in the second term of your expansion. K is equal to 2 in the third term of your expansion. So k is always 1 less than the term you're trying to find. So in this case, we want to find the third term, so k is going to be equal to 2. Okay, so it's always 1 less than the one you're trying to find. So in this case, if we input it into this awesome formula here, don't worry about sigma, we're going to find one term at a time. This is just saying all the terms. So I'm going to do n choose k. I'm going to do 5 choose 2. Then I'm going to take the first part of my binomial, which in this case is an x, and I'm going to raise it to the n minus k power, so 5 minus 2. Then I'm going to take the second part of my binomial and raise it to the k power. And then it's just a matter of simplifying. So you can either use Pascal's triangle to find this number or just plug it into your calculator, or you can use the combination formula, all of which we've practiced. So 5 choose 2 should give us 10. Notice this right here becomes x to the third because 5 minus 2 is 3. And then we've got a negative 6 squared, which is just 36. So if we multiply this 10 times 36, we get 360 x to the third. Now, again, we didn't have to multiply or expand this whole binomial to find one of the terms. And you may be asking, why do we want to find this term? It'll relate specifically to our probability. So we're just going to practice this a little bit. Again, don't worry so much about the sigma notation for now. It's part of the theorem, but you're just specifically finding different terms and different parts of the terms. So let's do this once more here. It says find each term described. So we're going to find the sixth term in the binomial expansion of x minus y to the sixth. So remember, n is equal to this power that it's raised to. So I'm going to start with n is equal to 6. And k is always 1 less than the term we're trying to find. So 6 minus 1 would be 5. I then use the formula and I do n choose k, so 6 choose 5. Then I do the first part of my binomial. I look over here, it's an x, so I do x to the 6 minus 5. The next piece is a negative y, so I do negative y to the k power as shown in the formula, and k is 5 in this case. We then go ahead and we simplify, so 6 choose 5 is equal to 6, and we have x to the first power, and we have a negative y to the fifth. So if I times this is like having a negative 1, right? And like y to the fifth, so 6 times negative 1 is negative 6, x y to the fifth. Let's try another one. D says find the fourth term in this expansion, x plus 1, 2y to the fifth. So again, I look at this and I say n is equal to 5, because that's the power it's raised to. If I'm trying to find the fourth term, k is 1 less than the term I'm trying to find, so k will be equal to 3. I then have n choose k. And again, when I'm setting this up, I'm just using this right here. So I do n choose k. Then you take the first part of the binomial, which in this case is a 1, and you raise it to the n minus k power. Then you take the second part, the 2y, and you raise it to the k power, in this case is 3. Then we go ahead and we simplify. So 5 choose 3 is 10. 1 to the second power, or 1 squared, is just 1. So I'm going to write it here. I don't really need to, just to recognize. And then 2 to the third is 8, and y to the third. If we multiply all of that, 10 times 1 times 8 is 80. We'd have y to the... Okay, in this next section it says find the coefficient described. So this one, it gives you a piece of the term, the variable part, but it wants you to identify what the coefficient would be. So essentially we just need to find n and k again, and then we'll use the formula and we'll calculate it out and find the coefficient, and hopefully the variable part of that term matches what we have here. So the n value is pretty simple to find. It's still that power that the binomial is raised to, so n is equal to 4. And then we're trying to find the k value. Just remember that on this first term in the binomial theorem, this is always n minus k. So if you just think about, well, 4 minus what is equal to 2, k must be equal to 2. Once we have those, again, we just set it up in the binomial theorem. So we do n choose k, or in other words, in this case, 4 choose 2. We take the first part of the binomial and we raise it to the n minus k power. Now you might be asking, do I have to do this part because I only need to find the coefficient? The answer is no as far as the v goes, but I would just multiply it all the way out as practice, and then the coefficient will come about. You'll be able to find it and not lose track of anything. So then we do this part raised to the k power. Alright, as we simplify, 4 choose 2, I believe is 6. V, 4 minus 2 is 2, so that's v squared. And then here we've got negative 3 squared, which is 9. And we've got u squared there. So as we simplify this, 6 times 9 is 54. And notice we've got that v squared, u squared, so we did find the right piece of the expansion. So the coefficient in this case would be 54. Okay, I'm going to do one more of those just real quick as practice. So coefficient of b in the expansion of b minus 4 to the third, so that's like b to the first right there, right? So again, if we look at this, n is equal to 3. And then we think about, okay, well, n, oh, I apologize. So we say n minus k should equal this exponent. So 3 minus k equal to 1. That means that k is equal to 2. So again, we set it up, 3, choose 2. And we take the first part of this binomial, b to the k n minus k power, so 3 minus 2. We take the second part of the binomial, and we raise it to the k power, just 2. So this is going to be 3 choose 2, which is 3. We've got b to the first power, so that's just b. And negative 4 squared is a positive 16. So 3 times 16 is 48. B, that looks great because that's the variable part they wanted us to find. So in this case, the coefficient there is 48. Again, your goal with this is to practice using the binomial theorem. So the goal really is to find the n and the k value, and then everything else will kind of fall in place and you'll be able to simplify. And it'll help a lot if you'll kind of show some work so that I